Hello, my name is Roy Simpson, and I'm professor of mathematics at Cosumnes River College in Sacramento, California. This is another video in my selected exercises for integral calculus here. And in this video, we're going to just go ahead and calculate the volume of a solid obtained by rotating a region about a line. And the line that we're going to rotate around is not an axis. So in this case, it's the line y equals -1, and the region is that which is bounded by cosine and sine on 0 to pi over 4. Now I happen to have a graph set up for this region, and I also have taken a slice out of that because it makes sense to slice this with respect to x rather than with respect to y. If you try to slice with respect to y for this region, you end up having to split it into two subregions. So if you can imagine that we slice with respect to y, we will have a region where, let's look at the upper region here, this region right here, we will have a region that has a right border being the cosine of x and a left border being the y-axis. And then all of a sudden, underneath this squiggly horizontal line, we have another region that has a right function that is sine of x, totally different function. So that means we have to split it up. And I just don't want to go about it that way. So instead, slicing with respect to x is probably the best bet. You also need to know where these two intersect, and they happen to intersect at pi over 4. If you're in calculus or calc 2, which you are if you're watching this video, you should also know that you should never rely upon a graphing technology to help you with this. You should be able to do this by hand. Okay, it's fine to check your work using graphing technology, but if you can't do this by now in a Calculus 2 course, then you're really going to have to back up. Calculus 2 is going to be way too difficult for you if you need a graphing utility to do a problem like this. All right, so let's go ahead and do this. Obviously, these washers that are going to rotate out will have an outer radius and an inner radius. And as we recall from our theory for the washer method or disk method, whatever you want to call it, the volume of a single slice, this guy right here, will have a width of dx and a surface area or frontal area, I guess you should say, of pi r squared minus pi r squared, where r sub outer squared is the radius from the center of rotation to the outer radius, and then r sub inner is the radius from the center of rotation to the inner radius. So let's go ahead and write down a function for that, and maybe I'll write it using a different color. All right, so the volume is going to be, let's see, we're adding up all those slices from 0 to pi over 4. And remember, you have a pi r squared for the, maybe I'll write r sub o, for the outer radius. And you're losing an area defined by the inner radius. And of course, you're taking your slices with respect to x. And as we saw on that picture there, I'm going to pull the pi out here, 0 to pi over 4. The outer radius, if you take a look at it, let me go ahead and write it this way, squared minus inner radius squared dx. If we take a look at this, the outer radius is going to be, well, the upper limit of the outer radius is the cosine function, and the lower limit is y equals -1. So it's cosine minus that y equals -1, or in other words, cosine of x plus 1. And then along the same lines, the inner radius there is going to be sine of x minus a -1, or sine of x plus 1. All right. Now all we need to do is some fancy arithmetic in here. And for the most part, this problem should be pretty straightforward. The only little bit that tends to be a frustration for students is that they forget an identity. When you multiply out this first one, it's cosine squared plus 2 cosine plus 1. So I'll write it out, actually, might as well. Cosine squared plus 2 cosine, even though you should be able to quickly kind of see where it's going here, plus 1. Next one will be sine squared plus 2 sine plus 1, but there's minus signs in front of that, so minus sine squared minus 2 sine, and then minus 1. And again, dx. Really, I like a bracket around that entire thing. I'm going to group things up, and notice the ones cancel. That's kind of nice. So we have this pi evaluated from 0 to pi over 4. And then we have a cosine squared minus a sine squared, which is going to be an important group. We also have a plus 2 cosine and a minus 2 sine. So all that arithmetic is pretty straightforward again. So this should be, again, very okay for a Calc 2 student. One thing you should remember is that cosine squared minus sine squared here, I'll just grab that up, is the same thing as cosine of 2x. That's from your trig or pre-calculus course. And so let's go ahead and write this out. Let me do this. So that's pi integral 0 to pi over 4. And we have the cosine of 2x plus 2 cosine of x minus 2 sine of x, and so on and so forth. And the antiderivatives here, let's see, pi. The antiderivative for the cosine of 2x is 1 over 2 sine of 2x. The antiderivative for the cosine is a positive 2 sine of x. And the antiderivative for the negative 2 sine of x would be a negative 2 cosine of x, or in other words, a plus 2 cosine of x. If you don't believe me, take the derivative of that. It is true. And then you evaluate these from 0 to pi over 4. So let's go ahead and plug in the pi over 4 here. 1/2 sine of 2 times pi over 4 is the same thing as sine of pi over 2, which is 1. Okay. Plus, plug in a pi over 4 to sine there, and you get 2 over root 2. Plus, plug in a pi over 4 to the cosine, and again, you get 2 over root 2. Now let's take care of our minuses. Minus, when I plug 0 into the sine, it's 0, so we don't care about that. Minus, again, when you plug 0 into the sine, it's 0, so I don't care about that either. Minus, when you plug 0 into the cosine, it's just a 1, so 1 times 2 is 2. And now we go ahead and combine like terms. Let's see, 1/2 minus 2 is negative 3/2. Two of these fractions with a root 2 on the bottom, plus another 2 of them would be a positive 4 of them. And that's as good as it gets. You can keep the pi on the outside, or you can distribute it in. If you distribute it in, you get 4 pi over root 2 minus 3 pi over 2. And that's it.